Linear regression and classification widely used in the field of machine learning. In this short video, I will use linear regression to train my salary data and then predict my model. So I basically need the data. You can easily download the data. Just type net salary.csv and you get website kaggle.com. So you just download from it, and this actually is the file. When you have downloaded this file actually look like this. In the first column it has year of experience, and in the second column it has a salary. So I'm to train my model, I basically do some steps. Just import my libraries, read my data, store my data into the variables, reshape my data, and then split my data between the training and testing session, and then I apply machine learning such as training and then predict my model, and I also make some graphs. So in the first step I'm just importing some important libraries such as pandas, scikit, import train test split, linear model, import linear regression. So basically linear regression nothing more than y is equal to mx plus c equation, and finally matplotlib. As so now actually I want to read my data. For that I will use just one command, read underscore csv. So my data basically in the working directory, I have stored this file in the working directory, so I don't need to put a whole address. I just write file name. Now I want to store my data into the experience variable and salary variable. So experience column data will store in the experience variable, and salary column data will store in the salary variable. For that I will use index location method. So my actual file at the data variable, and I use index location method. So in the first variable I am interested this first column and all of the rows. To select all of the rows I will use column symbol, and for the first column I will use 0. Here is for first column. To select for first column, up to this I just get indexes, but I am actually interested with values. So now I will do same thing for the salary, just change 1 instead 0. Now I get second column. So now if I see my data, it seems okay. Now I want to reshape that data. Just type reshape. Same thing for the salary. Now I want to split my data between the training and testing purpose. I will split 70% of I want to keep 70% of my data for the training purpose and 30% of my data for the testing purpose. So very easy. Train y, test y, just use train test split, and then data variables, and test size just use 30% of data, and random state I'm here typing 10. Up to this I have nothing to do about related with machine learning. Now basically machine learning has the two stages. one is training section, in which we train our model. For instance, we train in such a way that I use 70% of my data to train my model in such a way that someone year of experience has 1.1, then salary should be this. If someone year of experience is 1.3, then salary should be this. If someone year of experience is 1.5, then salary should be this. I show my model and train my model up to showing 70% of data. The beauty of scikit is, first of all, I am here importing linear regression. The beauty of scikit is there is only one code to train my model, which is fit. We use fit function and just show 70% of data, train x, train y. Okay, now actually I train my data, but now I want to test my data. I want to see how my model is trained. So I just provided 30% of testing data. I just provided year of experience data, and see what my model predict the salary. So for instance, lim.predict, I just give my model only year of experience data, and now I am expecting my model predict salary. So now we see print. Okay, if we print, actually we see test. Okay, I want to see index 2, and now I want to see what my model predict of index 2. Let's see, original value actually is 56,642, and my model on predictor 54,187. Actually this seems pretty good. It seems close to the real value, and we can improve our prediction through least square method. So now I want to plot my data. Just plt dot scatter, and I train x, train y, color green, and test x, predict, title, just say, for instance, I say experience and salary chart, x label, and then y label, which actually is a salary. Now here we go. Now we see what happens. So here is our chart. If you see, okay, this actually green dot is our trend data, and this is our predicted model. We will deeply study the mathematics behind the regression, but up to this